Isaac Newton, a renowned physicist of his time, defined 3 laws, which introduced the concept of gravity and revolutionized the world of science. These laws stated that an object in motion tends to stay in motion, and an object in rest tends to stay at rest. Force equals mass times acceleration, and every action has an equal and opposite reaction. In order to reinforce these ideas, we will be showing you 2 examples of each law at play. Let's get right into it!
Newton's first law of motion states that an object at rest tends to stay at rest unless acted upon by an outside force, and this isn't being acted upon by any outside net forces, so it's not moving. But when I give it an applied force, it moves, and yeah.
According to Newton's first law of gravity, an object at rest tends to stay at rest unless acted upon by an external force. Absolutely no motion. However, an object in motion tends to stay in motion unless acted upon by another force. So, it only stopped being in motion once it was acted upon by the outside force of normal force, aka the ground.
Newton's second law states that force equals mass times acceleration. So when I push this sled, its mass is relatively low, so its acceleration goes higher, and it goes further. So now that I added this log, the mass is higher, so when I push it, with the same amount of force, it doesn't go as far because the acceleration is lower.
Oh, hey there. So, according to Newton's second law of motion, force equals mass times acceleration. So, if I drop this tiny rock, it won't really make much of an impact. However, if I drop this much bigger rock, much bigger impact, simply because it has more mass, though the acceleration is the same, 9.81, according to gravity.
Newton's third law states that for every action there is an equal and opposite reaction. So when I kick this ball into this pot, the ball hits the pot, but the pot hits the ball with the same force.
Oh wow, you're still here? Alright, so, this is Newton's third law of motion, which is every action has an equal and opposite reaction, which is also the most famous one. Alright, so if I throw this basketball at the ground, it bounces up, which is the equal and opposite reaction, because instead of going down, it goes up. Science. Thank you so much for joining us on this demonstration, and we hope you have a fun physics day. We'll catch you next time.